NOAA's GOES-U satellite into space to keep a watchful eye over the Western Hemisphere, helping scientists and meteorologists to issue timely warnings and forecasts.
T-minus 30 seconds.
This will be NASA's Launch Services Program's 16th mission for NOAA.
A great partnership over the years we've had. Looking forward to this launch.
15 seconds.
And here we go. 10,
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Go, go, you.
Liftoff of GOES-U, NOAA's newest weather satellite, to monitor the Earth and Sun in high definition.
Hear that all pressures on the engines look nominal. Things looking good as you see the Falcon Heavy soaring towards the heavens. All 27 engines powerfully lifting GOES-U on its trajectory and ascent into space.
A beautiful shot as we
Power
track
and telemetry nominal.
the rocket from the ground here. The rocket is now powering down for max Q. Max Q is the moment of maximum dynamic pressure on the rocket. Max Q expected at 1 minute 7 seconds. The vehicle is now supersonic,
Falcon Heavy is supersonic.
traveling faster than the speed of sound.
Max Q.
There we heard the call for max Q, maximum dynamic pressure on the Falcon Heavy. Vehicle still performs very well. All the data looks nominal.
A great shot from on board the rocket, looking down on the Earth that it is leaving. And all 27 Merlin engines providing 5.1 million pounds of thrust. Coming up at T plus 2 minutes and 28 seconds, the side boosters are going to shut off while the center core will continue on. Wow, what a shot there of, again, all 27 Merlin engines firing off 5.1 million pounds of thrust.
The side booster cutoff will be referred to as BECO. We'll hear that call out. And then when the center core shuts off later in flight, we'll hear that called as main engine cutoff, or MECO. Side boosters are all boosters are performing nominally. Everything's looking good with the 27 Merlin engines.
Side booster separation confirmed.
There we see BECO and side booster.
MVAC chill.
Side booster separation. The MVAC is being chilled down, getting ready for ignition once the center core.
NY boost back startup.
And there we heard the call out for boost back startup.
A lot of things happening here. So again, we have the 2 boosters that are going to be returning to the Cape here, landing at landing zones 1 and 2. These 2 boosters have 3 burns, so we're seeing a boost back burn
All
now.
vehicles are following nominal trajectories.
Essentially, these boosters have flipped back and are returning on a path to the Cape here. There will be 2 more burns, a re-entry burn and then a landing burn. And these are going to provide quite a show for folks that are here on the Space Coast, because you're going to hear those sonic booms, Mick.
Yeah, absolutely. We are looking forward to those sonic booms as the side boosters landing zone 1 and 2. We're about 26 seconds away from main engine cutoff and the center core separating. Once the center core separates, we will then have MVAC, which is the Merlin vacuum engine for space, start up and get ready for what we call SES-1. Number 1. Today we have 3 burns for this mission to get GOES-U on its way, and this will be the first of those 3 burns.
TY boost back shutdown.
There we hear the 2 side boosters have boost back shutdown.
And now we're going to watch live footage there. There you go, of MECO. Again, the core
and back ignition
booster separating from the second stage, and the MVAC engine on that second stage lighting up. You see that on the right side of your screen.
We're about 4 seconds from fairing deployment.
Fairing again is
All
the two
vehicles continue to
halves.
follow nominal trajectories. Fairing separation confirmed.
And there we have confirmation the fairing has deployed. The fairings are brand new fairings for the GOES-U mission, and they will fall back to Earth and be recovered by the recovery ship Doug. But SpaceX will look to reuse those fairings on a future flight, along with the side boosters. As we see there, they're coming back to Earth to land on landing zone 1 and 2. So things are progressing very well here. We are about a minute and 23 seconds from what we call the entry burn, where the plus Y and NY side boosters will fire up their engines to start slowing down the vehicle as it gets ready for landing.
Yeah, a lot to watch. Again, the left side of your screen, we are tracking the boosters that are coming back to the Cape here. On the right side of your screen, that is the MVAC engine on the second stage that continues to burn as it makes its way into the correct orbit to drop off GOES-U later today.
Stage 1 FTS is saved.
There we hear the autonomous flight termination system was saved as it returns back to Earth, making sure the vehicle is in a proper configuration for landing.
The second stage is currently taking GOES-U across the Atlantic towards southern Africa. And this is the first time, actually, a GOES satellite is launching on a Falcon Heavy. Only the second time NASA's Launch Services Program is using a Falcon Heavy.
Yeah, we launched our first Falcon Heavy with SpaceX back in October of 23 with the Psyche mission. And the side boosters actually that we used on the Psyche mission will be used for our future mission, Europa Clipper, this October. So brand new hardware today for GOES-U, and everything looks like it's performing very well. All the telemetry, everything looks nominal for the flight so far today.
Yeah, those who typically watch our launch
EYNY
broadcasts.
entry burn startup.
There
That
we heard the
is-
call out for entry burn startup. The vehicles are slowing. You can imagine this as a brake on your car where it starts slowing the boosters back down very quickly as they...
EYNY entry burn shut down.
And there we hear the shutdown as the boosters have slowed down. Next thing we will see is the landing burn
EYNY FTS is saved.
at landing zone 1 and 2.
Beautiful
All
imagery
vehicles continue
again
to follow nominal trajectories.
from the ground as we track those boosters make their way back to the Cape. We saw some birds fly into the camera's view as
Hey,
well.
Everybody wants to see the landing
Exactly.
of the side boosters. As we said earlier, Megan, the landing will be exciting for a lot of people to see. Getting 2 side boosters coming back to landing zone 1 and 2, we will get those sonic booms. I know that you here in the MDC, we will get some.
EYNY transonic.
We will
Stage
get
2 FTS is saved.
we will get some loud shaking right here in the Mission Director Center. I know a lot of people right here in Brevard will be excited when they hear the sonic booms.
EYNY
my-
landing burn.
Landing burns has
Stage
started
2
up.
terminal guidance.
Wow, look at that. As it guides its way back down. Woo! Just heard the 2 sonic booms here in the room.
EYNY landing light deploy.
Our monitors
that.
shaking
That
as we
looks
watch
amazing.
these 2
That is
boosters
just
land.
awesome to see the 2 side boosters choreograph their way down to landing zone 1 and 2.
EYNY landing confirmed.
We have successful landing of the 2 side boosters. Everybody looks great on the landing zone 1 and 2 as MVAC continues its mission with this
Seco.
first burn. And there we heard the call out for SECO, which is SECO 1, second stage engine cutoff for this first burn. And things look very
Nominal
good. The
orbit
trajectory
insertion.
looks... We hear the call out there that nominal orbit insertion. Everything looks great on the second stage performance for this first burn, Megan.
Yeah, and what you're looking at now, everyone on your screen, is the trajectory for the second stage of the Falcon Heavy with GOES-U. So again, it's making its way across the Atlantic towards southern Africa. This was the first of 3 burns for the second stage. The second stage will now coast for about 18 minutes before reigniting for its second burn. And if you look at the bottom of your screen there, we have a progress bar full of our milestones that we're covering during during this live launch broadcast. And SES-2, that is that second burn we are talking about that will happen in, again, about 18 minutes from now. So, Mick, as you said, so far, so good. Really exciting launch.
Very exciting launch, and we got through that weather, and GOES-U's on its way.
Yeah, very dramatic and appropriate weather.
Absolutely.
As we and the launch team navigated that to see us lift off from the Space Coast at 5:26 p.m. Eastern Time.
Louisiana to the northeast. For meteorologists at NOAA's National Hurricane Center in Miami, NOAA's GOES-16 satellite provided the advanced high-resolution imagery for closely tracking Ida and developing accurate forecasts from start to finish.
We did see in the GOES imagery the development of that low-level center that allowed us to go ahead and call that a tropical cyclone.
But for Hurricane Ida, it was a case of there being more than meets the eye, literally. Within the eye of Ida, GOES-16's advanced baseline imager saw 4 mesovortices. A mesovortex is a small-scale rotation in the eye wall of a tropical cyclone, and it can be a telltale sign that a storm is getting better organized and intensifying.
Yeah, when we started to notice the mesovortices in the eye, that was during a period of time when we were starting to see some pretty dramatic inner core structural changes.
And with those changes within Ida's eye, scientists saw its wind speeds go up and its central pressure drop. Both of those changes can make a hurricane's winds and storm surge more destructive and deadly. But Ida still had a surprise after it made landfall. The mesovortices in its eye continued to spin around the eye even while it was over southern Louisiana.
It's quite unusual for us to be able to see the mesovortices, say, hours after landfall. And the reason is because after a storm comes ashore, it typically loses its fuel source. It loses its the warm ocean water, and that causes the storm to weaken.
But Ida's mesovortices were still visible over land because of what scientists call the brown ocean effect. Researchers have found that some tropical cyclones can maintain their strength long after landfall, or even strengthen over land, by tapping into the abundant soil moisture below it.
We think that the reason that the storm remained strong in this case was due to the presence of that marshy land. So it was almost like the hurricane didn't know it was over land. It thought it was still over the warm ocean water.
Hurricane Ida will definitely be a storm for the history books, and its full impacts are still being tallied today. For future hurricanes that threaten the U.S. and elsewhere, NOAA satellites will be our eyes in the sky to help forecasters stay on top of these monster storms.
T plus 14 minutes. Everything's good with the spacecraft and rockets so far. Let's check in now with NASA leadership. Philip Hargrove is with NASA's Sandra Connolly.
Yes, thank you, Daryl. I'm here with the Deputy Associate Administrator for NASA's Science Mission Directorate. Thank you so much for being here, Sandra.
Thank you so much for having me.
Yeah, I mean, what a day, what a moment. What was the launch experience like?
You know, absolutely fabulous. Beautiful launch. I could not be more thrilled. I have to say, I'm privileged to have seen several launches. Gorgeous day, and I actually got to see those boosters land. Fabulous.
What a show. So beyond the launch itself, what's exciting about the GOES-U mission for you?
So GOES-U is so important. As you know, it's the fourth in a series of geostationary satellites that actually support our weather, whole weather forecasting system. And so they stare over the U.S. or over the actual whole Western Hemisphere and provide us really critical data as storms are forming and evolving so that we can be prepared in advance of, during, and actually support after storms occur. So it really is an important satellite system for us.
Awesome. Can you talk a little bit about this connection between NASA and NOAA and how that has developed over the years?
Yes. So we have had a partnership for 50 years with NOAA. We have been building these kind of spacecraft. We develop them, we launch them, we commission them, and then NOAA operates them. And it's to support both terrestrial and space weather. Space weather is basically the sun's sending energetic particles towards, well, it's throughout the solar system, but it's when it comes towards the Earth that it can sometimes impact our power grids and cause problems for us here on Earth. So it's important to study space weather as much as it is terrestrial weather.
Awesome. And can you tell us about what's next in this NASA-NOAA collaboration?
Yes. So again, we've had a long-term partnership, so we continue to plan for the future. So there is a GeoXO series that is going to be the GOES R series follow-on. So we're very excited to be partnering with NOAA on that. But also NASA has, on the space weather side, we have a mission called IMAP that's launching in the springtime. And we have a rideshare mission called Space Weather Follow-On, which is a NOAA mission. So we're going to be advancing our work in space weather as much as terrestrial weather.
Awesome. Very exciting stuff. Thank you so much for being here. Glad you got to witness that in person. And yeah, thank you again.
Thank you. It's fabulous.
All right. I'll send it back to you all.
Thank you. And we've been talking, of course, about GOES-U and the mission as we continue to